Hello, ladies and gentlemen. The next thing we're going to be going over is linear versus nonlinear functions. So we're determining whether the given function is linear or nonlinear based on the information we're given. So linear functions have a constant rate of change, and they look like a straight line, one single straight line. A nonlinear function have a variable rate of change, meaning that it's not the same. So when we're looking at a table of values, what we're looking for is a constant rate of change. So to get from -3 to 0, I would add 3. To get from 0 to 2, I would add 2. To get from 2 to 5, I would add 3. Because of this positive 2 here, that does not have a constant rate of change. If that positive 2 was a +3, it would be a constant rate of change, and I would look at the y side and see if that is a constant rate of change. So this one is nonlinear. Okay, because of that +2, okay? Now, to get from 1 to 16, we would add 15. To get from 16 to 26, we would add 10. And to get from 10 to 41, we would add 15. So that, again, is not a constant rate of change, so therefore it is nonlinear. On a graph, we're just looking for a straight line. This is obviously not one single straight line, so this is nonlinear. On the last one, on an equation, we're looking for the variable x and y to both have exponents of 1. As long as the exponents are only 1 and there's no absolute value, which would look like this, no absolute value, no log of x, no special stuff like that. This equation is linear. So looking at our problems below, so we're going to do the same thing for our table. So -4 to 2, we would add 2. To get from 2 to 0, we would add 2. To get from 0 to 4, we would add 4. So because I got to a different rate of change, this is nonlinear. Okay. Looking at number 2, x and y are both just regular variables. There's nothing special about them. This is linear. Number 3 is obviously a curve. It is not a straight line, so this is nonlinear. Next one, number 4, we have y equals x squared plus 4. Because of that x squared, it is nonlinear. Number 5 is obviously a straight line, so this is linear. And then on number 6, to get from 1 to 2, we would add 1. To get from 2 to 3, we would add 1. To get from 3 to 4, we would also add 1. So that's a constant rate of change. So far, so good. On the other side, to get from 2 to 4, I would add 2. To get from 4 to 8, I would add 4. So this one's nonlinear. Okay. Now, if that was +2 down the chart, then that one would have been linear. But because of that +4 and +2, that's not the same. So that means nonlinear. So that's it for this video. Thank you for watching, and have a